what does it says? Now law of chemical combination consists of two main laws. One is law of conservation of mass and second is law of constant proportion. These two laws were the main basis of my laws of chemical combination. Okay, law of conservation of mass, जैसे ये word आता है conservation of mass, आपने और भी कहीं पढ़ा होगा. When I talk about law of conservation of mass, इसका मतलब क्या है हमारे पास कि मास को हम ना तो क्रिएट कर सकते हैं ना डिस्ट्रॉय कर सकते हैं. टोटल मास किसी भी सिस्टम का उतना ही होगा. यू कैन चेंज इट्स फॉर्म, आप उसको अलग अलग टाइप्स में चेंज कर लोगे, बट उसका कंटेंट जो है, मास जो है, उसको आप चेंज नहीं कर सकते हो. ओके, इफ यू स्टार्ट विथ सम मास, at the end also you are going to have the same mass. Okay, so law of conservation of mass was used in chemical reactions also. So it was said, if you talk about law of conservation of mass, let's see what does it says. It says that it was given by Lavoisier in 1774. Okay, what did it say? That matter is neither created nor destroyed in a chemical reaction. किसी भी chemical reaction में ना तो कुछ extra create होगा ना destroy होगा, खाली the atoms are going to rearrange themselves and form new compounds. They are going to rearrange themselves. Okay, nothing is going to be lost nor be gained. That was the concept given over here. In other words, I can say in a chemical reaction, the total mass of the product, whenever reaction takes place, the total mass of the product is equal to the total mass of the reactant. जो भी react करेंगे, for example, in short, I can say, what does it says that if you have a chemical A, let's take A, and I am combining with B, then I will get C plus D or only C. कुछ भी हमने क्या किया इसके अंदर, A के साथ B को रिएक्ट किया तो क्या बना हमारे पास C and D. तो what does this law says कि जितना मास स्टार्टिंग में था हमारे पास A और B का मिला के जो भी मास था, the same mass will be available by combining C and D. C और D का मास भी जब आप कंबाइन कर दोगे तो उसका मास भी इसके बराबर ही होगा. So this is the reactant side, this is the product. Reactions में हम यही लिखते हैं, इधर reactant लेफ्ट हैंड साइड में, राइट हैंड साइड में हमारा प्रोडक्ट है. तो जितना मास हमारा reactant का है उतना ही मास हमारा प्रोडक्ट का होगा. This law is called as law of conservation of mass. So in any chemical reaction, it is always valid. Okay, this is only why sometimes आपने पढ़ा होगा बैलेंसिंग अ केमिकल रिएक्शन. क्या जरूरत है बैलेंसिंग करने का? इसी लॉ को फॉलो करना है हमको. To maintain this law that the mass of reactant is always equal to the mass of product, we have to do it. Okay, so this was the law. Actually, clear? So it was given over here. The first law for chemical combination is this one. Okay, co-experimental. If I want to show you in some experiment, I can say that this is an example of a reaction. This is calcium carbonate. If you heat it, it breaks. Decomposition takes place. Breaks का मतलब decomposition. इसके जो molecular formula में कुछ changes आएंगे. So we have calcium carbonate. If you decompose it by heating, if you heat it, it decomposes into two chemicals. One is calcium oxide and other is carbon dioxide. It breaks into two compounds, calcium oxide and another is carbon dioxide. Okay, it breaks into two parts. Now if we talk about the mass, if I am breaking 100 grams of calcium carbonate, कितना break करें हम यहाँ पे 100, what do we get over here? 56 grams of calcium oxide and 44 grams of carbon dioxide. If you add 56 and 44, what do you get? 100. Reactant कितना था? 100. जितना आपका reactant का mass है, product का mass भी उतना ही होगा. This law says, this is the law conservation of mass. Is it clear? So it is given over here. This is being valid over here. Okay. One more experiment. You can see this experiment being done over here. We are taking two chemicals. Okay. Experimental verification के लिए experiment to verify the conservation of mass conceptually. Okay. So it is just given theoretically है ये भी. Experiment आप lab में जाके कर सकते हैं under the guidance of some teacher. So here what is the experiment being done over here? We have a flask in which we are having two chemicals. One is barium chloride. This solution, a barium chloride solution, and in the test tube over here I am having sodium sulfate solution. Sodium sulfate and barium chloride. ओके। नाउ टेस्ट ट्यूब इज हेल्ड बाय अ थ्रेड, ओके। तो हम क्या करते हैं इसके अंदर, इसका हम वेट कर लेते हैं, मास निकाल लेंगे पहले, ओके। मास कैसे ले लेंगे, हमने कितना ये ले लिया केमिकल, दोनों केमिकल अलग अलग नाप के हम कुछ लेके यूज कर सकते हैं इसके अंदर, ओके। एंड देन इस धागे को, if you move this thread and make the test tube dip inside so that both the chemicals react, I'll get another compound. When these two reacts, barium chloride and sodium sulfate, when these two react, I'm getting barium sulfate and sodium chloride. Two different chemicals are formed. I've used two chemicals and my result is two different chemicals. What about mass? So if you weigh initial weight or final weight, दोनों का अगर आप measure करके check करोगे, you are going to get the same, okay. When we did this experiment, so I took somewhat like this. I took these two solutions, barium chloride solution was 20.8 grams and sodium sulfate was 14.2 grams, and when these two were reacted, the resultant we got over here was barium sulfate and sodium chloride. The resultant over here I am getting 23.3 grams of barium sulfate and 11.7 grams of sodium chloride. This is the resultant. These two are my reactant, these two are my product. हुआ क्या इसके अंदर, reactant का मास कितना है, if you combine 20.8 and 14.2, 20 and 14 is 34 and 0.8 and 0.2 is 135 grams. प्रोडक्ट कितना मिला हमको, 23 and 11, 34, 0.3, 0.1, 35. 35 ग्राम्स हमने रिएक्ट किया, 35 ग्राम्स हमको प्रोडक्ट मिला ओवरऑल, ओके। हम इंडिविजुअल के मास कंपेयर नहीं करते हैं, ओवरऑल मास ऑफ द रिएक्टेंट हैज टू बी इक्वल टू ओवरऑल मास ऑफ प्रोडक्ट, ओके। सो अगर इस टाइप के चीज में, इस टाइप से कोई किसी क्वेश्चन में अगर हमको ऐसा मिल जाए, आई एम रिएक्टिंग दिस टू दिस, आई हैव ऑब्टेन्ड, व्हाट इज द मास ऑफ दिस, इसका मास कितना है, किसी एक का मास अगर मुझे निकालना है, आई एम गोइंग टू यूज द सेम कंसेप्ट that the mass of reactant equals to mass of product and I can get the unknown quantity जो हमको ढूंढना हो, we can get it, okay. we will try this question also. कहीं पे हमको एक unknown mass निकालने को आ जाए दो reactant के साथ में, we will do that also, okay. So here it is given here, mass of the reactant was 35 grams, mass of the product was 35 grams, 35 35 बराबर, nothing lost neither gained, ना तो कुछ पाया ना कुछ खोया. So what is here, since the total mass of my reactant equals to my total mass of product, so this reaction followed law of conservation of mass. This reaction was, it verifies the law of conservation of mass, okay. So clear what is law of conservation of mass, mass can neither be created nor be destroyed, okay, or I can say the total mass of reactant will be equal to the total mass of product for any chemical reaction, okay. Second law, okay, that was law of constant proportions, okay. This was given by Joseph Proust, it was given in 1779, okay. Joseph Proust, he laid this, he suggested, I can say, that in any chemical compound means which is made up of two or more than two types of atoms. So chemical compound consists of the same elements combined together in the same fixed proportion by mass, okay. A chemical compound, take any chemical compound from here or from there or anywhere, you take same type of chemical compound, you are going to get the same type of element, okay. For example, if I talk about the salt which we eat, okay, नमक जो घर में हम खाते हैं, उसमें क्या कंपाउंड होता है, डू यू नो, इट कंटेन्स सोडियम क्लोराइड, Na है and Cl, it has two things, Na, सोडियम एंड क्लोराइड. अब उस नमक को आप कहीं से भी ले आओ, you bring it from anywhere, the same salt खाने वाला, bring it from market or this place or that place or here, you are always going to get NaCl only in that, NaCl ही मिलेगा उसमें, वही एलिमेंट. So a particular compound is made up of same element made be from anywhere, उसी एलिमेंट से बनेगा और वो दोनों एलिमेंट उसी रेशियो में हर जगह मिलेंगे, NaCl, okay. For example, I was talking about NaCl, Na और Cl है, one atom of sodium, one atom of chloride, that is making my compound, okay. So कहीं से भी ले आओ आप नमक, you are going to get these two in the same ratio. If there is 10 Na, then it will contain 10 Cl also, okay. So I can write it as 10 NaCl, 10Na, 10Cl. The ratio between both of them is 1:1. The ratio between the number of atoms, you can say, of sodium and chlorine is 1:1. It's going to be 1:1. The ratio in terms of number of atoms or the ratio in terms of mass. If you want to calculate the ratio in terms of mass also, it's going to be same for any of the compound brought from anywhere for the same type of compound. Okay, उस same type of compound आपने कहीं से भी लाए, उसके अंदर आपको ratio same मिलेगा, यानी कि उनका जो proportions है, it is always fixed. Okay, so the law says a chemical compound always consists of the same elements combined together in the same proportions by mass. Here they are talking by mass. Example है हमारे पास, let's check it out. Water, water is H2NO. Water क्या हमारे पास H2O. Okay, so यह हाइड्रोजन का मास 1 होता है. ठीक है, कुछ चीजें हैं जो चैप्टर में बाद में पढ़ेंगे, नेक्स्ट चैप्टर में भी, बट यहाँ पे हम उसको यूज कर रहे हैं. मास ऑफ अ हाइड्रोजन एटम, that is 1. We take it 1 unit and we have 2 hydrogens, so that is 2 total. Oxygen has a mass 16U, so that is 16, and if you take out the ratio, you are going to get 2 1 ja 2 8 ja, so 1:8. In a water molecule, from any source, you take the water molecule, कहीं से भी ले आओ पानी को, आप कुएं से ले आओ, नल से ले आओ, टंकी से आओ, रिवर से ले आओ, कहीं से भी. If it is water, okay, so it is formula is H2O, fixed. You are not going to get H3O, you are not going to get HO2, you are not going to get H2O2. Formula उसका H2O ही रहेगा. One molecule of water is going to contain 2 atoms of hydrogen and 1 atom of oxygen. Okay, from anywhere you get it. तो रेशियो क्या है उनका, मास, मास का रेशियो हम निकालें तो क्या मिल रहा है हमको, मास का रेशियो 1:8. If I talk about the atom ratio, it has 2 atoms, this is 1 atom. The number of atoms will be 2:1. 2:1. So for 2 hydrogen, we are using 1 oxygen. अगर मेरे पास 40 हाइड्रोजन हो जाए, जितना हाइड्रोजन है उससे आधा ऑक्सीजन चाहिए. अगर मेरे पास 40 हाइड्रोजन है तो 20 ऑक्सीजन लगेंगे फॉर्मूला बनाने के लिए. ओके, क्लियर. इनका रेशियो फिक्स्ड होगा बाय नंबर और यू कैन से बाय मास. द रेशियो बाय मास विल बी 1:8 always. If you want to verify it, let's see. Let's take 10 molecules of H2O. एक मॉलिक्यूल, अब हम कितना लेके आ गए, 10 मॉलिक्यूल्स लेके आए. नाउ लेट्स टेक हाउ मेनी हाइड्रोजन इज देयर. 10 मॉलिक्यूल्स में कितने हाइड्रोजन आ जाएंगे हमारे पास, 20. तो 20 हाइड्रोजन का मास कितना हो जाएगा, 20U, बिकॉज हाइड्रोजन मास इज 1. तो 20 हाइड्रोजन एटम्स विल हैव 20U. ऑक्सीजन, दैट 10 एटम्स ऑफ ऑक्सीजन, उसका मास कितना होगा, एक ऑक्सीजन का मास होता है 16U. 10 का हो जाएगा 160U. So again I can cancel 28 जा, I am getting 1:8. कितने भी मॉलिक्यूल ले आओ, कहीं से भी ले आओ, रेशियो मेरा 1:8 ही रहेगा फॉर ए गिवन कंपाउंड वाटर. ओके, सो दिस इज लॉ ऑफ कांस्टेंट प्रोपोर्शन फॉर एनी काइंड ऑफ कंपाउंड. उसके मॉलिक्यूल्स का मास का रेशियो या नंबर ऑफ एटम्स का रेशियो सेम रहेगा. यहाँ पे कार्बन डाइऑक्साइड का भी एक एग्जांपल दिया हुआ है. यू हैव एन एग्जांपल ऑफ कार्बन डाइऑक्साइड आल्सो, CO2. इट कंटेन्स carbon and oxygen. Okay, anywhere you bring carbon and oxygen, the ratio over here is 3:8 by mass. If you want to verify it, let's see. We have the formula CO2. Carbon 1, carbon has a mass of 12U and oxygen again 16. So 16 2s are 32U. I can cancel 4 3s are 4 8s are. The ratio is 3:8. We got it. So that is it. So law of constant proportion says that for any compound the ratio by mass is always fixed. Is it clear? So this was the two laws. One was law of conservation of mass and this law of constant proportion. Okay, so these two gave us the idea about the combination of the molecules in a compound. It remains the same, mass can neither be created, कोई भी reaction होगा mass same रहेगा. Okay.